They had never seen anything like it. A massive polar bear mother, one of the Arctic's most devoted parents, was swimming away from her tiny cub, stranded alone on a floating piece of ice. Researchers watched in horror, expecting the worst. But what they discovered about why she left her baby was something that would revolutionize everything we know about polar bear intelligence and sacrifice. Because in that moment in the harsh Arctic wilderness, thousands of miles from any human help, maternal instinct turned into something else, something we rarely witness in nature. Strategic thinking, calculated risk, and a kind of love that requires the ultimate sacrifice. Before we begin, subscribe to the channel. Hit like and turn on notifications, because the story you're about to hear will make you question everything you thought you knew about animal intelligence and the lengths a mother will go to save her child. The remote research station on the edge of the Beaufort Sea in northern Canada was one of the most isolated and challenging scientific outposts on Earth. Perched on the frozen coastline, where the tundra meets the Arctic Ocean, the facility represented humanity's farthest reach into one of the planet's most unforgiving environments, where temperatures regularly dropped below -40 degrees Fahrenheit, and where polar night lasted for months during the darkest winter periods. This extraordinary research station had been established 12 years earlier by a consortium of international Arctic research organizations, including the Canadian Wildlife Service, the World Wildlife Fund, and several major universities. The facility was specifically designed to study polar bear behavior in their natural habitat during an era of unprecedented climate change that was rapidly transforming the Arctic ecosystem. The station was staffed year-round by a rotating team of dedicated polar bear researchers who had devoted their careers to understanding these magnificent creatures in their rapidly changing environment. The scientists who worked at this remote outpost represented some of the world's leading experts in polar bear ecology, wildlife behavior, and Arctic conservation. Dr. Sarah Mitchell had been the lead polar bear researcher at the station for over 12 years and had observed thousands of interactions between mothers and cubs during her distinguished career. She had earned her doctorate in Arctic wildlife biology from the University of Alaska Fairbanks, where she had specialized in polar bear maternal behavior and cub survival strategies. Sarah's research had taken her to some of the most remote and dangerous locations in the Arctic, including multi-month expeditions onto shifting sea ice, where she had documented polar bear behavior that had never been observed by humans. She had published over 40 peer-reviewed papers on polar bear ecology, and was considered one of the world's foremost authorities on polar bear intelligence and social behavior. Her research team included Dr. James Chen, a wildlife behaviorist from the University of Toronto, who specialized in animal cognition and learning; Dr. Lisa Rodriguez, a marine biologist from Woods Hole Oceanographic Institution who studied the impact of climate change on Arctic food webs; and Dr. Michael Torres, a veterinarian and wildlife health specialist who monitored the physical condition and health of the polar bear population. The research team had been tracking a particular mother polar bear they had named Aurora for over 3 years, using advanced satellite collars, sophisticated drone surveillance, and direct field observation. Aurora was an exceptional bear in many ways and had become the subject of intensive study due to her remarkable intelligence and innovative behaviors. Aurora was a mature female, estimated to be approximately 15 years old, and weighing nearly 400 pounds during peak condition. She had been born in the wild and had never had any contact with humans until the research team began monitoring her as part of their long-term population study. What made Aurora particularly fascinating to the research team was her exceptional success rate as a mother bear. She had successfully raised 5 previous litters over her reproductive lifetime, with an unprecedented survival rate of over 90% among her cubs. This was remarkable considering that cub mortality in wild polar bear populations often exceeded 50% due to the harsh Arctic environment, predation, and environmental challenges. Aurora was also known for her exceptional hunting skills and her ability to adapt to changing ice conditions. She had been observed using innovative hunting techniques that had never been documented in scientific literature, including the use of ice formations as hunting platforms and sophisticated strategies for approaching seals that demonstrated remarkable intelligence and planning ability. Aurora had given birth to her most recent cub the previous winter in a carefully constructed maternity den carved into a snowbank approximately 50 miles from the research station. The den was located in an area that provided optimal protection from harsh weather while offering easy access to the sea ice where Aurora would eventually need to hunt to sustain herself and her growing cub. The cub, whom the research team had named Nanook after the Inuit word for polar bear, was a healthy, active male who had been developing normally under his mother's devoted care. For his first 8 months of life, Nanook showed all the signs of a thriving polar bear cub. He was growing rapidly, learning essential survival skills and displaying the playful curiosity that was characteristic of healthy young polar bears. Polar bear mothers are renowned throughout the scientific community for their fierce devotion to their cubs and their willingness to sacrifice everything for their offspring's survival. They often go without food for months while nursing and protecting their young, burning their own body fat reserves to produce the rich milk that sustains their cubs during the critical early months of life. The bond between polar bear mothers and cubs is considered one of the strongest and most enduring relationships in the animal kingdom, with mothers defending their young against all threats, including much larger male bears who sometimes view cubs as competitors or potential prey. The maternal protective instinct in polar bears is so strong that mothers have been observed fighting to the death to protect their offspring. But on a cold September morning that would forever change the research team's understanding of polar bear behavior, they witnessed something through their high-powered telescopes and sophisticated drone cameras that challenged everything they thought they knew about polar bear maternal psychology. Using state-of-the-art observation equipment positioned on elevated platforms around the research station, the team was conducting their regular morning survey of polar bear activity in the surrounding area when they spotted Aurora and Nanook on a large ice floe approximately 2 miles from the nearest shoreline. The ice floe was substantial, measuring roughly 200 feet in diameter, and appeared stable enough to support both bears. Safely, Aurora and Nanook had apparently swum to the floe earlier that morning as part of their regular movement pattern following the shifting sea ice in search of hunting opportunities. What the research team observed next defied all scientific understanding of polar bear behavior and challenged fundamental assumptions about maternal instinct in one of nature's most devoted mothers. Aurora carefully positioned her 8-month-old cub on what appeared to be the most stable section of the ice floe. She spent several minutes inspecting the ice surface using her powerful paws to test stability and safety. Then she guided Nanook to a specific location that offered the best protection from wind and the most secure footing. The care and attention she showed in positioning her cub suggested deliberate planning rather than random behavior. Then Aurora did something that left the entire research team speechless. She moved to the edge of the ice floe, looked back at Nanook once, and dove into the frigid Arctic water. She began swimming steadily toward shore, using powerful strokes that carried her away from her cub with obvious determination and purpose. Dr. Mitchell and her team watched in absolute shock and horror as Aurora swam steadily toward the distant shoreline, never looking back, while Nanook stood alone on the ice floe, calling for his mother with the desperate, high-pitched vocalizations that polar bear cubs make when they are distressed, frightened, or separated from their mothers. The sight was heartbreaking and completely unprecedented in polar bear research literature throughout decades of scientific study. Polar bear mothers had never been documented willingly abandoning healthy cubs, especially not cubs who were still completely dependent on maternal care for survival in the harsh Arctic environment. Polar bear cubs remain with their mothers for approximately 2 years, learning essential survival skills including hunting techniques, ice navigation, and predator avoidance. Abandoning a cub at 8 months of age was essentially condemning it to death, as cubs that young lacked the skills, knowledge, and physical development necessary to survive independently in the Arctic. The research team immediately began preparing for an emergency rescue operation, while continuing to monitor both Aurora and Nanook through their sophisticated observation equipment. They had protocols in place for intervening in wildlife emergencies, but polar bear rescues were extremely dangerous and complicated operations. They expected to find a cub in severe distress who would need immediate intervention to survive. The Arctic conditions were harsh, with temperatures below freezing, strong winds, and the constant threat of the ice floe breaking apart or drifting out to sea. But as they continued to observe Nanook's behavior through their high-resolution cameras and telescopes, they noticed something completely unexpected that forced them to reconsider their interpretation of what they were witnessing. The cub was not panicking or showing the extreme signs of distress that would be expected from an abandoned polar bear cub. Instead, Nanook seemed to be waiting calmly on the ice floe, as if he understood that this separation was temporary and that his mother would return. Nanook's behavior was remarkably composed for such a young cub. He explored the ice floe, methodically testing different areas with his paws, and seeming to assess the safety and stability of various locations. He positioned himself in areas that offered protection from wind and maintained visual contact with the shoreline where his mother had disappeared. Hours passed, and the research team tracked Aurora's progress as she reached the shoreline. But instead of disappearing inland as truly abandoning mothers would typically do, she positioned herself on a prominent rocky outcrop with a clear line of sight to the ice floe where she had left Nanook. Aurora remained motionless on her observation point, clearly watching her cub through what appeared to be a deliberate surveillance operation. She was too far away for Nanook to see her, but her positioning suggested that she was maintaining careful monitoring of her cub's situation. Dr. Mitchell began to realize that something extraordinary and previously undocumented was happening. Aurora had not abandoned her cub in the traditional sense. Instead, she was conducting some form of sophisticated behavioral test or training exercise that required them to be separated while she maintained distant supervision. Using advanced drone cameras to get closer aerial views, the research team observed that Nanook was displaying remarkably advanced survival behaviors for such a young cub, behaviors that seemed far beyond what should be possible for a bear his age. Nanook was systematically testing the stability of different sections of ice using his paws to gauge thickness and structural integrity. He was demonstrating understanding of ice safety that typically took cubs much longer to develop. He was conserving energy by remaining in sheltered areas during wind gusts and positioning himself to maximize exposure to sunlight for warmth. Even more remarkably, Nanook was attempting primitive hunting behaviors that were extraordinarily advanced for his age. He was watching intently for seals at potential breathing holes, positioning himself quietly near openings in the ice and displaying the patient stalking behavior that was characteristic of experienced hunters. The research team documented every aspect of Nanook's behavior during his time alone on the ice floe, noting that he seemed to be applying lessons that Aurora had apparently taught him during previous training sessions that the researchers had not fully understood at the time. After 6 hours of careful separation, Aurora dove back into the frigid Arctic water and swam directly toward the ice floe where Nanook had been patiently waiting. The reunion between mother and cub was emotional and touching, with Aurora immediately beginning to inspect Nanook's condition, checking him thoroughly for any signs of injury or distress. Aurora spent extensive time nuzzling and grooming her cub, providing comfort and reassurance through the physical contact that was essential for polar bear bonding. She seemed to be evaluating how well Nanook had handled the independence challenge and appeared satisfied with his performance. What the researchers had witnessed was not abandonment, but rather an extraordinarily advanced form of survival training that had never been documented in wild polar bear populations. Aurora was teaching Nanook essential skills for Arctic survival by allowing him to practice independence while maintaining the safety net of distant maternal supervision. This behavior suggested cognitive abilities, planning skills, and risk assessment capabilities far beyond what scientists had previously believed possible in polar bears. The level of strategic thinking required to design and implement such training exercises indicated intelligence that rivaled the most advanced animal species. Dr. Mitchell immediately consulted with polar bear experts worldwide, sharing video footage and detailed behavioral observations with colleagues at research institutions throughout the Arctic region. The unanimous consensus was that this behavior had never been observed or reported in scientific literature. Dr. Elizabeth Hamilton, a renowned animal cognition specialist from Harvard University, reviewed the footage and declared it revolutionary evidence of complex planning and educational behavior in polar bears. Aurora's teaching methods demonstrate intelligence, foresight, and sophisticated understanding of risk management that challenges fundamental assumptions about animal cognitive abilities. Over the following weeks, the research team documented Aurora conducting increasingly complex and sophisticated training exercises with Nanook. She would position him on ice floes of varying stability, teaching him to assess and navigate challenging conditions that he would need to master for independent survival. Aurora's training program appeared to be carefully graduated with systematic progression from simple to complex challenges. She slowly increased the difficulty and duration of independence exercises, while always maintaining the ability to intervene quickly if Nanook encountered genuine danger. The sophistication of Aurora's teaching methods was remarkable, She would demonstrate specific survival techniques, then allow Nanook to practice them independently, while she observed from strategic positions that allowed rapid intervention if necessary. Aurora taught Nanook advanced ice navigation skills, including how to assess the stability of different ice formations, how to move safely between floating ice sections, and how to identify dangerous conditions that should be avoided. She demonstrated sophisticated hunting techniques, including proper positioning at breathing holes, patient stalking methods, and the complex timing required for successful seal hunting. Nanook practiced these techniques under Aurora's supervision, gradually developing skills that would be essential for his eventual independence. Aurora's methods proved extraordinarily effective as Nanook developed survival skills and hunting abilities, far in advance of other cubs. His age, he learned to assess ice stability with remarkable accuracy, navigate dangerous waters with confidence, and even successfully caught his first seal at an age when most cubs were still completely dependent on their mothers for food. The research team's extensive documentation of Aurora's teaching methods revolutionized scientific understanding of polar bear intelligence, social learning, and cognitive abilities. Their findings were published in multiple prestigious journals, including Nature Science and the Journal of Animal Behavior. The publication of their research sparked international interest in polar bear cognition and inspired new research programs at universities worldwide. The implications extended beyond polar bear research to broader questions about animal intelligence and the evolution of teaching behaviors in wildlife. Dr. Elizabeth Chen, a cognitive animal behaviorist from Stanford University, called the observations groundbreaking evidence of complex planning and educational behavior in polar bears. Aurora's teaching methods demonstrate intelligence and foresight that rivals the most advanced animal species and forces us to reconsider basic assumptions about animal cognitive capabilities. Dr. James Morrison from the University of Alaska added that Aurora's behavior represented the most sophisticated example of animal teaching ever documented in Arctic wildlife. The level of planning, risk assessment, and graduated instruction suggests cognitive abilities that were previously thought to exist only in humans and a few other highly intelligent species. The story of Aurora and Nanook spread throughout the international scientific community and captured public attention worldwide. The research team received inquiries from wildlife educators, conservation organizations, and media outlets around the globe. Wildlife educators began incorporating the findings into educational programs about Arctic conservation, animal intelligence, and the remarkable cognitive abilities that exist throughout the natural world. The story became a powerful example of why protecting Arctic habitats was essential for preserving not just species, but also the complex behaviors and cultural knowledge that animals pass down through generations. Conservation organizations used Aurora's story to highlight the importance of protecting polar bear populations and their Arctic habitat, arguing that the loss of these remarkable animals would mean losing not just a species but also the sophisticated intelligence and cultural knowledge that they possessed. Years later, Nanook successfully established his own territory and began his own reproductive career, using modified versions of the survival training techniques his mother had taught him, proving that Aurora's methods were not just effective for individual survival, but could be passed down through generations. Nanook's offspring showed evidence of receiving similar advanced training, suggesting that Aurora's innovative teaching methods had become part of a family tradition that would benefit future generations of polar bears. The research team continued studying Aurora's family line over multiple generations and discovered that her advanced teaching methods appeared to have a hereditary component, with her daughters and granddaughters displaying similar sophisticated training behaviors with their own cubs. This multi-generational transmission of advanced teaching techniques suggested that polar bear intelligence and cultural knowledge could evolve and improve over time, creating lineages of exceptionally capable bears who were better adapted to survive in challenging Arctic conditions. Aurora's innovative parenting style became a symbol of the remarkable intelligence that exists in Arctic wildlife and demonstrated that animal mothers possess cognitive abilities, strategic thinking skills, and teaching capabilities that scientists were only beginning to understand and appreciate. The research station continued monitoring Aurora's family for over a decade, documenting the development and refinement of teaching techniques across 3 generations. The data provided unprecedented insights into how animal intelligence could evolve and improve through cultural transmission. Aurora's legacy extended far beyond her own family, as other polar bear mothers in the region began displaying similar advanced teaching behaviors, suggesting that innovative techniques could spread through polar bear populations through social learning and observation. The research findings contributed to new conservation strategies that recognized the importance of protecting not just polar bear populations, but also the complex behavioral knowledge and cultural traditions that these remarkable animals had developed over generations. Aurora's story became required reading in wildlife biology programs worldwide, and inspired a new generation of researchers to study animal intelligence with greater appreciation for the cognitive complexity that exists throughout the natural world. If this incredible story of maternal intelligence, advanced animal learning, and the remarkable cognitive abilities of Arctic wildlife touched your heart, don't forget to subscribe to the channel, hit the like button, and share it with someone who believes that the natural world holds intelligence, teaching abilities, and cultural knowledge that we are only beginning to discover and understand. Sometimes what appears to be abandonment is actually the highest form of love, and sometimes the greatest teachers are those who know when to step back and allow their students to discover their own strength, capabilities, and potential for survival. Aurora taught the scientific community that polar bear mothers possess sophisticated intelligence, planning abilities, and teaching skills that rival the most advanced species on Earth, proving that the Arctic wilderness holds mysteries of animal cognition that continue to challenge and inspire our understanding of intelligence, consciousness, and the remarkable bonds between mothers and their offspring. The long-term implications of Aurora's revolutionary teaching methods extended far beyond the immediate scientific community and began influencing conservation policy at the highest levels of international environmental protection organizations. The United Nations Environment Program incorporated Aurora's story into their Arctic conservation guidelines, recognizing that protecting polar bear intelligence and cultural knowledge was just as important as preserving the species itself. The World Wildlife Fund launched a comprehensive research initiative called the Aurora Project, dedicated to documenting and preserving advanced polar bear behaviors across all Arctic regions. The project involved collaboration between research stations in Canada, Alaska, Greenland, and Russia, creating an unprecedented international network for studying polar bear cognition. Dr. Sarah Mitchell was invited to present Aurora's case study at the International Polar Bear Conservation Summit in Reykjavik, Iceland, where delegates from 23 countries gathered to discuss new approaches to Arctic wildlife protection. Her presentation fundamentally changed how conservation policies viewed animal intelligence and cultural preservation. The economic implications of Aurora's discoveries were also significant, as increased research funding flowed into Arctic studies and polar bear conservation programs. Governments and private foundations allocated over $50 million specifically for cognitive research in polar bear populations, recognizing that understanding animal intelligence was crucial for effective conservation strategies. Aurora's teaching methods inspired new approaches to wildlife rehabilitation and reintroduction programs around the world. Conservationists began developing training protocols based on Aurora's graduated independence model for preparing captive-bred animals for release into wild environments. The psychological impact on the research team members was profound, as many of them described Aurora's story as the defining moment of their scientific careers. Dr. Mitchell often reflected that witnessing Aurora's advanced teaching abilities had fundamentally changed not just her understanding of polar bears, but her entire perspective on animal consciousness and the sophisticated cognitive abilities that existed throughout the natural world. Nanook's continued success as an adult bear provided ongoing validation of Aurora's teaching methods, as he established one of the largest territories ever documented for a male polar bear, and became known for his exceptional hunting efficiency and his own innovative techniques that built upon what his mother had taught him. The research station established the Aurora Memorial Laboratory in honor of the remarkable bear, whose intelligence had revolutionized polar bear research. When Aurora died peacefully at the age of 22, she had successfully raised 8 litters and had influenced an entire generation of polar bear researchers worldwide. The educational impact of Aurora's story reached millions of people through documentaries, museum exhibitions, and school curriculum programs. Children around the world learned about Aurora's advanced teaching methods, inspiring new generations to pursue careers in wildlife biology and conservation science. Aurora's legacy became a symbol of hope for Arctic conservation, demonstrating that even in the face of climate change and habitat loss, the remarkable intelligence and adaptability of polar bears offered reasons for optimism about their survival and continued evolution as a species.